So this is what we're gonna see today. So let's just get right into it. Now, what you can see is just a representation of a constant. Okay, constant is a number, and this is where you see when the amplitude is equal to 2. This is how we represent the constant. Okay, in general, and this that we have y, x, negative x, negative y. Okay, and when you have to represent x, for example, in this case, this is how you're going to represent x. Okay, this is how it when x is positive, and then this is what you get. Okay, and this is where it's going to start, and then this side it's where you're gonna get the amplitude. Okay, now this is an example of a quadratic equation. So x squared, you can just this shape for to represent the x squared, and this is for cubic. You're going to see this shape for cubic. Okay, now this is what we get from the some basics function. So now let's go into what we'll be covering today. Okay, today we're going to see the basics of a function. So let me just zoom in. Okay, and we're going to apply the system analysis. Okay, so in order for us to they're essential for modeling and predicting behavior of a dynamic system. Okay, and we're going to see what is a unit impulse, unit step, and the ramp function. Okay, so let me just show you what we get from the impulse or delta function. This is how we present it in t domain, and this is how we present it in discrete mode. Okay, so this graph you see here, this is the representation in terms domain of delta, and this one is how we present it into s domain. Okay, and even the quotations that you see there, and further on, this one is the unit step. Okay, and this is how we present in unit step in times domain, and this one is the discrete mode of the unit step. It's how you present it. Okay, and you should know it was something like this. We had something like this previously, and then when you convert it, it's going to remain with something close to this one. Okay, this is the discrete mode of a unit step. Now, when we go to ramp, this is ramp, and this is how we represent ramp. Actually, this is t, what you see. Okay, in times domain, and then when you present it in discrete mode, you get this shape. So it's gonna be like it's going to follow that pattern, but we're going to represent it with this discrete form. Okay, so these are the three basics function. There are more, so we're going just to show you those section, but there are more. For example, if I want to show you the exact representation, okay, so this is let me just go to this side so then you can see. Okay, so what you have here, it's the step, the unit step. This is how you draw the unit step. Okay, so it's going to start. You have 0 here, and here you got your amplitude. Okay, this is how you represent the unit step in times domain. Okay, and if you have to represent it into Laplace or apply Laplace transform, this is what you're gonna get. Okay, so this is what you're gonna get this case. Now we go for a ramp function. Okay, a ramp function, we're going to start here, and this is where you're going to start, and this is where we're going to, and remember, if I just connect them, this is where you're gonna get your amplitude. Okay, and this slope, it's t. Okay, for ramp function. So that's why you see we get a times t. Okay, and also in S domain you get something like this. Alright, we have also a parabolic function. This is also another function, but we're not gonna speak much about this one. This is where you have your starting point where you have 0. Okay, this is where the amplitude is. So we're gonna find a this system. Okay, so that's what you see, and this one is gonna be t square. Okay, and of 1 over 2. This is what you're gonna get here. So it's gonna be this 2, the amplitude times the slope. Then you're gonna get this one in times domain. And if you have to convert it into Laplace transform, you can actually look at the table for Laplace transform. Actually, you're gonna get this. Let's just get a recap of what we just saw. Okay, this one is the impulse. We're going to assume this is where we're going to have our amplitude. We know already this is 0. Okay, so if I have to write this in S domain, it's gonna be just a representation of a impulse. Now let's go, and this is where we have our amplitude. Okay, and this one is actually where we have 0. So this is a unit step, and the representation of a unit step is gonna be in S domain, it's gonna be a over s. Okay, and since a equal to 1, as you can see, it's gonna be 1 over s, which is our unit step representation. Okay, and it's more because we have this unit and our amplitude is equal to 1. Okay, so the same goes for this other equation. Okay, so I'm going to just connect the dot. This is where we have 0. This is where you have the amplitude and function of t. Okay, like for example, here it was 1 all the way up to here. You see, so this is, now we're going to see what equation we're gonna get for our, it's gonna be a times t. Okay, so, and then if you have to write this into our S domain, you will get something like this: a over a square. Okay, and since a equal to 1, it will be 1 over a square. So these are the formulas that we're going to use later on. Okay, we're going to also focus on those 3 that you see here, and maybe we'll just focus on those 3 and maybe touch a bit of parabolic equation, but our main focus is more on how we can use a unit impulse as our input, unit step as an input, unit ramp. Okay, depending on what you're going to have later on. So this is it.